Hi everybody, welcome to my next part of the Linux command line tutorial, and in this video we're going to see how regular expressions work, or for short you call them regexes, and I'm going to show you a few examples by using them in the commands grep and z, and we'll see how powerful they are in order to match text in text files. In detail we're going to see how not only to match characters within a line, but also how to match the beginning and the end of a line in a text file. We're going over quantifiers, which are basically operators that tell the regular expression how many of the character you're specifying you want to match in that place. How you can group expressions together, and we'll see what character classes are and what back references are. For that we'll use z. These are some strange words maybe only to you now, but I'll try my best to explain to you how you can use them and how they work, so you hopefully afterwards, after watching this video, you can go and try your own examples. Okay, so let's get started. Once again, I have put together a simple file with some kind of text like this, some lines with some A's, a few lines with B's, and A B stuff, and A B B, and so on, as you can see for yourself. So first of all, we're going to use egrep, which is the regular expression enabled version of grep, and I'm specifying the E flag with a capital E because that enables some extensions for the regular expressions, and that's quite useful usually. So, and then you can of course tell the command or tell our grep command some regular expression you want to filter your text file through or yeah. So first of all, you can of course grep. That's nothing special. You could use the regular grep for this. What happens here is we pipe the contents of our file into the grep command, and it matches or it prints the line whenever an A appears in a line. So what we are seeing here as a result are all lines in which at least one A appears. Similar is the double A. Now we see lines in which at least two A's appear. So now, before we continue with some more complicated stuff, let's make this. And now I have to explain. The caret matches the beginning of a line, and the $sign matches the end of a line. So what we'll see now when we invoke this command should be we should just see the line with two A's in it and nothing more. Yeah, and that's it. So when I remove this, we will see lines in which have two A's at the beginning of the line. Exactly. And the other way around, just to make it clear, we will see only lines which have two A's at the end of the line. Like this. As you can see, we don't see the lines here anymore with the B's because they don't match, because there's not an A at the end of the line. Okay, so that's it for matching the beginning and end of the line. I explained this at first because this makes some examples more obvious, I could say. The next thing I want to show you is a quantifier. Quantifiers, there are three types of quantifiers. A question mark is the first one I want to show you. This means, or the quantifiers always relate to the character you specify before them, or the pattern character you specify before them. So this question mark here relates to the A before it, directly before it. And the question marks quantifier tells the regular expression or defines, hey, this A can be there or cannot be there. So it's making this A optional. In this combination it's quite useless because well, you should see, yeah, okay. We obviously see the line where just a single A is in there, because what we specified here is, hey, I want to see lines in which directly after the beginning of the line I see an A or don't see an A, and then it should follow, what should follow is the end of the line. So that's why we see the line with a single A in it and every empty line, because this A is optional. That's what we told this here with the quantifier, the question mark quantifier. When I remove this, the empty lines will be gone, or we won't get these as a result, because then the A is no longer optional. So that's the first quantifier. The next one is the plus quantifier, and that is, for example, why I usually specify this extended regular expression option, because the plus quantifier is not included in the very basic default original version of regular expressions, and you have to enable it usually by specifying extended versions of regular expressions. Okay, so what the plus quantifier means is, it also relates, as I said, it also relates to the A before it. And what it means is, hey, I want at least one A, but it's also okay if there are more than one A, or if there's more than one A. So it's also okay if the A appears multiple times, more than once. So that means the plus means once or more than once, related to the character before it. So what we should see here then now is lines with that start with an A, at least have one A there or more, and then end without anything between it. And that's it. So as you can see, we have lines at least with one A or more, and no lines with a B in between or something, because we tell the regular expression, hey, we want the end of the line right after the A's here. If we leave out the, once more to make it clear, maybe once again, is if we leave out this one, the end of line matcher, then we will also see the lines with the B's in the end. Yeah. And even as we see, we even see these here, because there's the beginning of the line and at least one A. So this line matches. But for clarity, I will insert the end of the line matcher again. And so that's how you can specify. Let's say we have this, and what this means is I have a non-optional A, I have another non-optional A, and then I have another A which should be there once or more than once. That means we will now see lines which start with 3 A's and optionally more A's than that, and then have an ending in the line. Yeah. So maybe once again, the difference to the question mark quantifier is this now means, hey, we have a line that starts with two non-optional A's, two A's that must be there right after the beginning of the line, and one optional A. So what we should see now is two lines, one with two A's in it and one with three. So yeah, as you can see, this is the difference to the plus quantifier. The plus quantifier says, hey, this A is not optional. Once again, this plus here relates to this A, but not to these. These are still literally must be literally there in the line that matches. Okay, the next quantifier and the last one is the asterisk sign, and this one is you could say a combination of the previous two, because it means, once again, it relates to the character before it. It doesn't relate to the first two A's here, but it relates to the A before it, directly before it, or in front of it. It says, hey, this A here can appear 0, 1, or more than 1 times. So it includes the optional stuff here, but it also includes the more than once stuff of the plus here. So what we'll see here is this. So the difference here between this one and this one, as you can see, is that in this result we also see the line with just two A's in it, because the asterisk says this A is optional, or can be optional, while the plus says this is not optional, it must be there at least once. Okay, really complicated, huh? I'm just thinking about whether I can show you a few more examples that make this clear. Let's see this one. Okay, we don't have any examples of this. Okay, there we see another example. Now, this line here matches because we have a line starting with two A's that are non-optional, and the line ends with B's, at least one B. So that matches. And this one now matches another line because the asterisk says, hey, the B can be optional, it doesn't have to be there. The A's, once again, must be there because there's no quantifier specified behind them. Okay, now the next topic is grouping. You can group characters. For example, let's say or first of all, grouping is done by using parentheses like this, and you can then specify the optional groupings. So this will either match a line with two A's or two B's. This pipe here is read as OR. As you can see, it prints the line with two A's or the line with two B's. That's what grouping is. Because otherwise you would only be able to to tell, or the OR would just be relating to characters directly besides it. That's why you have the option of specifying the parentheses that make clear which part of the string is part of the option in this grouping. Okay, next one, character classes. Now it starts getting interesting. You can say with the brackets here, the square brackets, you can define so-called character classes, which is some parts of some characters. And what this means here is match a line which consists of exactly one character which is either an A, B, C, D, E or F. So that doesn't mean match a line that contains all of these, but it means match a line that starts by saying beginning of line and then defining a character class that defines which characters are valid for this position, and defining end of the line. So we will see these two lines because A and B are specified here, so A and B are valid options in that very position here. C, D, E and F don't occur in our file, so that's why we don't see any. When I take out the A, I will only see the B line. Now let's combine these together with our quantifiers. We can say, hey, we want to see lines that once or more have this one of these characters in a row. So that is why we see now A and B. When we put A back into the mix, by the way, this is not ordered, it's a set, so the order doesn't matter here. Then we see almost all the lines because this one matches because it is a sequence of characters that match characters within this character class, and they occur at least once. So this one matches this expression here. If you specify the asterisk quantifier, then we should also see empty lines because it tells the quantifier now relates to the entire character class when putting it after the character class, and it says, hey, this whole thing is optional, so empty lines match as well, as we can see here. Now this is interesting because it lets you get a lot of variation into your patterns that you want to match. And there are a few predefined regular expressions, no, not regular expressions, character classes, which, for example, or which usually are denoted like this. For example, this one is the character class that defines spaces, and it doesn't matter whether it's really a space character or the tab character. So we want to match this. Then what we see here is the empty lines that we have in our file. It's maybe not a great example because when we start this, we will not get any line because there are no empty lines in our file. So, but let's put some in there. And now here I insert a line that consists just solely of spaces. And then this one, when we put this here, this matches. So that's the line we just put in there, the spaces. Okay, and maybe one more thing that I forgot to mention is there are even more complex quantifiers. For example, you can specify at least 3 times and at most 5 times. So that doesn't match anything. I don't know how many. Yeah, okay, so obviously I put 6 spaces in there. So what this means, this is a quantifier as well, the curly braces, and you can say once or more. This is valid here. It says 1 or more spaces is what this means, the entire expression. This expression means, hey, in match 2 or more spaces, 3 or 4 or more, and now 7, but we only have 6 in our line, and that's why we don't get a result when we type 7. Similar to this is up to 4 spaces, and that's why we're getting the empty lines now, because they contain 0 spaces. 1 to 4 spaces, 2 to 4, 2 to 7, and then we get our line with the 7 spaces again, or 6 spaces. Yeah, so, but this is quite an advanced quantifier that's not always available everywhere. But as you can see, when you enable this extended flag here, you can use this and it works. Okay, so that's it for... Oh no, that's not everything about character classes, because what you can do is AB, like this, for example. That's a good example again. What we're saying here is, hey, match either an A or an B, and match to a match a sequence that consists of 3 or more of A's or B's. So that's why we are matching this, because we have 3 A's. This is matching this because we have 3 or more A's, and again same with B's, and also these combinations here, because we have a combination of A's and B's and 3 or more of them. So but what I wanted to show was you can negate a character class. So this one, then it's the character again, but it in this position it means not beginning of the line, but it negates the character class. So what you can do here now is, or what this means now is, match anything that is not an A or B. So for this file we should probably get nothing, because let's again add some lines. Let's say, for example, C. And now when we say at least once, then we get the space line with the 6 spaces in it, and the C line that we just inserted into our file. Once again, this means match a line that begins with a character that is not A and not B, and occurs at least once. So match a sequence of characters that are not A's and B's, and then the line should end. So that applies to the C line here, and also to the line that contains our spaces, the 6 spaces we inserted earlier. Okay, and just the other way around, you can of course negate the predefined character classes. So this here says, hey, match a line that doesn't doesn't start and end with spaces. So you can see that now we're getting all the A's and B lines and also the C line, but missing is now our space line with the 6 spaces in it, and also the empty lines, because we said at least one character must be there that is not a space character. Okay, that's complicated, I know. You have to get used to it and try around yourself a bit maybe, but sometime you'll get your head wrapped around this. There's one more topic, which is the background references. I have still my Z file here a little bit modified. You see a lot of spaces in it that make it look ugly. It's the file I had in the Z tutorial video. And now I would like to show you a example of back references using Z, because these don't make sense really with grep. Okay, so once again, remember our Z. We're telling it, hey, substitute, the substitute command. The R is enable extended regular expressions. And now we're telling it we can make use of our predefined character classes. We can tell it, hey, replace any kind of space or white space that occurs once or more than once, and replace it with anything. Do that globally and then not just once for each line. Now what we can see is the spaces got replaced by underscores here. And what we want to do is remove them all together. So we specify an empty replacement here. And that removes all spaces from our file so that it looks nice again. So what you can do with that is specify several expressions, or several commands, not only one, by specifying the E flag for, I think, for expression, that is. We can now tell it to do another substitution. So these execute from left to right. So this one is going to be executed first, and this is the second. And what we can do now is, for example, we want to mark, or how you would call it, Frank, and let's say Anne. What we can do now is take a grouping. That's, well, as we learned before, a grouping which matches either the string Frank or the string Anne. And what is implicit for these parentheses is that these create a back reference. A back reference is something that you can refer to in your replacement expression here. You can say, for example, replace Frank or Anne with note. Do that globally. And when we fire this, then Frank gets replaced by note, and Anne just the same. but that doesn't help us much because we want to keep the name there after the node, and so we say \1. And now what happens is Frank got replaced by node :Frank everywhere where it appears, and also Anne got replaced by node :Anne. So this is a reference to the first parentheses expression within the matching string here, or the regular expression here. If we had something else here, I don't know, whatever, and another parentheses expression, then you could refer to that by \2, so that these get enumerated from left to right, starting at 1. Very nice. That allows you to do a lot of things. By the way, one thing I haven't mentioned yet is the dot, which matches any character. So we could say, what's a good example for this? Let me think. Yeah, okay. So we have Tim and Tom. So we could say match either Tim and match Tom. So now we have Tom prepended with the node string that we specified here, and we have Tim replaced by this same thing. You could also, instead of this one here, you could also say no, dot, because dot matches any character. As you can see, node Tom, node Tim. You could also say, if you want to be more specific, as we've learned, IO, which is a character class. So this is one character, either an I or an O. And this again gives the same result. Yeah, or let me think. You could also say not a space character. Also the same result. Okay, you see, the combination of all these features of regular expressions can get you really complicated expressions in a very well, yeah. When you combine it, it gets really complicated very early and very soon. I think that's it for now. So maybe I will prepare another video that shows some more advanced examples, because there are some traps you can fall into when starting to use regular expressions. But this is it for now for this video. Thanks for watching.